We are going to be solving Codeforces round 794. So let's read the first problem. We are already late and we have not even registered for the contest. So the first problem states that you are given an array and you have to choose n minus 1 elements of the array and replace each of them with their arithmetic mean. And is it possible to make all elements of the array equal by performing a finite number of such operations? Okay. So let's take the input first. We have t test cases, then we have n number of integers, and then we have an array. So we just have to print yes or no if it is possible or not. 42 is already that thing. In this case, we can make all of the elements, take all of the elements and convert it to, no wait. We can do these two to 3 and then we can do 5 and 1, 2, 3. Okay, you can also take all of them. Whatever is this thing. So we can't do this thing, which is weird that we cannot do this thing. So we can't do this one. So I can't think of the logic here. So let's say there are x, y and z numbers, or let's say xy numbers, and you can take average of only one. Then if x is not equal to y, then you cannot make these equal, of course. And then if x, y, z is the equation, then you can make this to be equal to x plus z by 2 or x plus y by 2, let's say, and you can make this to be x plus y by 2, and this will remain z. And if you can somehow figure out that this z is actually equal to the sum of the other two and divide by 2, then we can. That is one way. Is there any other way, like can we take an average of these and then put them? But that won't ever be equal to this because this will be the number here. So average of this comma something else will never be equal to this number. So this has to be equal to x plus y by 2. So basically what this means is if we find the sum, which will be a long or int, we can take an int. So if we find the sum and if we take a loop and if we subtract from sum the value of that index, so basically want x plus y by 2, or x plus y by 2 can be written as sum I of every term except that term. So that would be, and we can replace by 2 by the number of integers, that would be n minus 1. And if a of I is equal to this, then we can say that we can do it. And we can, in the start, we can take flag to be false. So we assume that it is not possible, and if we find a case where this is possible, then we just say that that is possible. Let's run this before submitting, and also we have to register for the contest before I can finally submit. Oh, this came out to be a wrong answer. So what went wrong? So in this case, let's see which guy is this where this is coming out to be true. P of I. So for 2, we can see that the sum of every other element, 4 plus 3, 7 plus 8 divided by 3, which is not happening. So let's print out this thing. Oh, maybe the divide operation is actually rounding it off or something like that. Yeah, so 8 is not divisible by 3. That means so we just have to add one more condition, that it should be perfectly divisible. So we can do that by saying mod of this when taken should be equal to 0. Let's please submit. How do I submit? Let's look at the second problem. Odd subarrays. So for an array b1, b2 up till pm, define its number of inversions. We know that. Be odd if its inversions is odd. If you are given a permutation of integers from 1 to n, each of them appears exactly once. I want to split it into several consecutive subarrays so that the number of odd subarrays among them is as large as possible. Okay. So in this question, the input so we have n and then a permutation. We could have just copied what we did here. So we take in the permutation. Let's look at a couple of examples. Each test case output a single integer, the largest possible number of odd subarrays. So we don't need to find those subarrays, we just need to print out the largest possible number of odd subarrays that you can get after splitting the permutation. Okay, so in the first permutation there won't be any because there is no inversions. So in the second one there is one inversion here, second inversion here, third inversion here. So 3 inversion. 4, 3, 2, 1 both which are odd since the numbers of inversions are 1. So this had 3 inversions, but if we did this and this came out to be 1 inversion and this came out to be, oh, this actually had 3 inversions with 4, 2 inversions with 3, so 5, and 1 inversion with 2, so basically 6. Now I forgot the algorithm to find inversions. There was like probably a very good technique to find it using mod sort by, so it reduces the time complexity somehow. Okay, so we can use this code. So we would use it like this, in which we pass the array and the size of the array. Right, so we do like a and then pass n, and you can store it in a inversion count. So now we have the number of inversions, but what would we do with that? I don't know. So 1 and 2 there are no inversions, 2 and 1 there is 1 inversion. So we know that at minimum, so these are like the lower bound. So these many inversions would be present in that whole subarray. So what we need to do is basically divide this array such that the number of inversions increase, or no, basically if I have misunderstood the question, so we want to increase the number of odd subarrays. So basically if this is odd, then we have count as 1. If inversion mod 2 is equal to 1, then count is equals to 1. Right, so now we have to separate our inversions somehow. Right, somehow we have to separate. How will we separate? Can we get the indexes of inversions? This is like all of these are like count inversions. Count. How can we get the like indexes at which the inversion is present? So can I assume that? No, I can't. So this basically did nothing. So we might need to understand this algorithm, then we can maybe get indexes. So if this number is like even, then we can either make this to be 1 1 1 1 4 inversions, or we can do 3 and 1, right? So 1 and 3 and so on, because both of these are odd and we have to maximize the number of odd inversions. Or we can do 1 1 1, but that would be the same. Can we do this? This would also mean the same, right? Because the number of odd subarrays, odd inversion subarrays are still 2. So this would also work. So basically, if this and this are same, what we can do is we can go in the array, search for an inversion, like pick if time complexity permits, which it does not. So what I was thinking was like an O of n square solution where that is not possible. The fifth test case, we can split our permutation into subarray this 4 to 5 and 6 1 2 3. So that is the same thing now. So this anyway had 3 inversions as a full subarray. So this was pointless. Okay, what I was thinking was maybe fix this number, then look for a smaller number than this inside this, and pick the first number and we break there, right? And then in this array we look for a number that is smaller than this. If we don't find, we go for the next. So this approach might be of n square, but because in the worst case scenario this list would be sorted and we would just take this and then traverse this, we take this and then traverse this, and we won't find anything. So that is an O of n square approach, but maybe we can reduce the complexity by using this thing, but we just have the count of inversions. Let's say display so this is O of n square, I suppose. So basically the index of inversion cannot be found in less than O of n square time, because we are printing Okay, maybe it is, maybe it is not. But the number of inversions can be much larger than the, so like the number of inversions can be an offense square, so that is also no use. So what do we do now? uh, so we just have to look for a place where this spike occurs. So this is a greater thing, right? And let's say if I draw a graph, so here's a peak and here is a low point, then you just have to find this thing wherever this occurs, and it doesn't matter if this goes above or below. You just have to look for a pattern where this occurs. So what we can do is we can keep a count of max till now. Wait a second. Okay. And max till now is equals to, is it positive numbers only? Yeah. Oh, we did not optimize on these being a permutation of integers, so maybe we can do something with that. So this is a permutation of, so the numbers are 1 to n, which means, what does that mean? I can never think of an optimization for this. I always try and solve for a general purpose, and I always forget that the array is actually a permutation, and we can optimize something on that. What can we optimize on? Let's just do this. So we do for loop again, and this time, so max till now is equals to max of f1 comma max tn f of I is lesser than max tn. That means this is not the greatest guy, so there was some greater guy that came before this, so we can split here. So basically split after this, so include this in the subarray. So how do I do a split? And I assign max tn to this number, of course, because we cannot map it with any other than now. So what I'm doing is basically, now if I split here, now I will only have like one inversion inside of that array, and I can safely increase the count is equals to 0, and when I split I can do a counts plus plus. So I made an array like this, and if in the end also if I get the value of what will I do in the end. So where was that graph? So this was the graph. So what if at the end I get a lesser number? So that would be taken care of here. Wait, I'll increase the count here only. Right. So if I end up here, then I do not need to add to count because this cannot be mapped with anything. Is it the correct approach? Like getting ones, one here, probably a correct approach. Probably. See what counts. Zero. Okay. That means this thing is failing. Let's do a cout. So what I'll do is I'll do a cout if I, and if this is true I'm gonna place a, let's say a stick here, and we'll give an inline for the answer. So this guy right here, oh, we did a merge thing, right? So we don't want to do that. So this is coming out to be 3, but instead this should be 2. So we can get at most 2. So this was a 4 and then 3. So that was one inversion. So we broke here. Then we found out to, oh, okay. So the A of I cannot be the previous guy because that was included in the previous array. So max Tn again becomes what? 0, I guess, because now the max Tn would be this at all costs. I can also make it to be A of I plus 1, but that would break at the end case, so I plus 1. So let's do this. Now it's fine. I don't know if it's the correct way, but because counting inversion shouldn't be this easy, right? And now I can remove this code. Or I can just this. Let's read the problem C. That is, let's see what others are doing. Oh, they got a -1. Let's try circular local minimax. That means this problem is difficult. If okay, you are given n integers, is it possible to arrange them on a circle so that each number is strictly greater than both its neighbor or strictly smaller than both its neighbors? In other words, check if there exists a rearrangement of the integers such that for each I, at least one of the following condition holds. Either the middle one is so it's like a wave sort algorithm kind of, but in this is like circular also. So to make sense of the previous formulas for I equal to 1 to n, one shall define that b0 is equals to b of n and b of n plus 1 is equals to b1. Okay, so we have input and then so on. So how did we did a wave sort before? So we just have to, no, we also have to find the configuration if it is possible. So I thought we just have to print that if it is possible or not. Right. So the input, how will we take the input? I'm gonna copy the input here. Now we get AFI and then we don't need the sum, or do we? We don't need it. Also this AFI is 10 to the power 9, so some variable would be a long if we ever want to create one. And yeah, that's it. Just like any other thing, let's search for wave sort. So will O of n square solution work? Will O of n log n work? I hope n log n works, but t is pretty large, but that is fine, I think. Okay, first we sort, then we swap adjacent elements. So this is simple solution. Now we need the better solution. Oh, there is no better solution. Of and time by single traversal. The idea is based on the fact that if we make sure that all even position elements are greater than their adjacent order, worry about odd positioned elements. If current element is smaller than previous odd element, I think I'm gonna go with the sort one. Because this is kind of, and also we have to make sure that this is also in wave with this, and this. and this is in wave with this, this, and this. How will we make sure that that is true? So what that means is, if we are starting a wave like from the top, so this, 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 so the ending of this, nah, that doesn't mean anything. I was thinking like, if we start the wave from up, then we should end at a low. But what if the low of this wave is still greater than this high of the wave that we started with? We can make additional condition for that. I think I'm gonna just sort the array, and by sorting it, what that would do is basically this would give me an array something like 1, 5, 7, 8, and now what we have to do is have to swap I and I plus 1, right? So they have written their own swap function. Why? That is weird. Wouldn't swap work on its own? And why have they passed the array by reference when it is always like passed by reference? Whoa. Or why are they giving address? Okay, let's see if this prints out a wave, and then we can think about the last element and the first element. Okay, this is not even printing the array. Let's see out. So the array should be something like, no. So this is not working. Oh, so the elements are unique in this, or what? So if the elements are unique, then this swapping won't work. Anyway. Oh, but this works for the second test case. 1849, wow. So if I make this here 1, 8, 4, 9. So this would be surrounded by 1. This would be, it's a 9. So this is like a downhill. So just like this. Then from 1 we go to 8. Then from 8 we go to 4. 4 we go to 9. 9 we go to 1. So this is all working. Wow. He has not solved this till now. Linguistics. Let's try this. Linguistics. Local minimax. So this question reminds me of de Broglie wavelength, because it was somewhat like that. Whiteboard. So it was like so it's like the worst one. So if this is considered the wavelength, this should be like an integer multiple of something. So in a wave like this, or in a wave like this, right, we just have to make sure that this end, if this is like a high, so if this end is smaller than this thing, then it would make sense, right? But if this thing is greater than this thing, then this would be like, this would not hold that property, right? So yeah, so that works. So we'll start from a high, so we should end at a low, plus higher should be greater than low. And if we start at a low and end at a high, then also, so that would look like this. So this high will be connected with this one and it makes like this. So what does this mean? And why are we doing this? Plus, how can we check if there's a configuration which can achieve that, how can we make sure that this happens? So if we sort it, then we already know that it is possible. But in this case, we are seeing that it fucks up. Okay, so 4 is here, 4 is here, 1 is here, 9 is here, 8 is here. Now 8 and 4 both are below, so this fucks up. So, but what if I would have swapped something else? So 1498. So now that this is in increasing order, sorry, this is not in increasing order. Now that this is in increasing order, does it have to be in increasing order? Then we can swap these two and these two and these two. But let's say if I swap these two, so that would be 184. Right. And then I keep these as it is. Then this works, right? Yeah, this works. Let's consider another example. Let's say 1, 2, 1. Let's say 1, 2, 3, 4, 5. Now I swap these two, 3 and 2, get 5 and 4, and now 4 and 1. So this is ending on a high. No, this is ending on a low, because this is lower than 5. So if we have an even length array, we should swap from I plus 1. And if we have an odd length array, and what if both of them fail? Then we print out no. And how do we check that it is satisfying it? We can make a checker function maybe. So to make the checker function first, we are doing test driven development here. So so before writing the actual function, we're going to create a test for it. So we traverse the array, and if I is equals 0, then we would make b0, or we would check b of n minus 1 with something, right? Or So one more weird thing I noticed is that this is not less than or equal to. So this should be strictly smaller or strictly greater. So what does that mean? What I'm doing right now is basically checking if this is like going like this. That this is like a point and this is again going upwards, or it is going downwards and the other guy is also going downwards. So I'm checking this condition. So b of I is less than equal to b of I plus 1. So this case, and b of I minus 1 is less than equal to bi, then in this case b of I is greater than b of I plus 1 in this case, But now I'm thinking that if they are equal, then all of this is false anyway. If b of I is equal to b of I minus 1, or b of I is equal to b of I plus 1, then it is false anyway. We don't even need an AND of this. So flag equals false break. You can also give this as a next if statement instead of ORing right now. So what we can do is if this, then do this. I'm sorry. Then do this. So what this means is basically if this should be removed now because we have handled that case here, and now I can copy paste this inside of others as well, but with slight changes. So for this case I plus 1 would not be present, so I plus 1 would be replaced by 0, and here also 0, here also 0, and let's try this first. So in this case I minus 1 won't be available, so this would be replaced by n minus 1, or n minus plus, no, n minus 1 only. This would be n minus 1, right? And all of this, after doing all of this, we use another term, flag. So we can probably make a function of this, and we could have also made a function for this, but that would be too much of refactoring required for a competitive programming problem. So bool check int the array and an length, right? That's all we need for this thing. So if check is true, then we print out yes, and we print out this think whatever we calculated else we print out. No. And you can name it Cheku or Checky, and we can be like old Checky is equals to check for A with the length of A. Now for the replacing part, so since we have made sure that the last number will be the highest, because we are sorting, right? We have sorting, so that means since the last number is always large, so when we encounter an even array, that means we should start with small, end with a big one. And for that, if we have an even array, we are supposed to replace this, and let's say this and this, so we are going to replace this and this, right? So our swapping will start from 1 if n mod 2 is equal to 0. Can we do this? But what if like we could arrange in another sorted order or sort descending and then do the opposite of what we did right now? Okay, we'll see later. So we start from 1, we swap this, and we do not swap this, right? So I think that will be taken care of. Let me just test this. So what I'm trying to do is basically wait, what was this for? I did not put a curly brace. How did this curly brace come? So what was this curly brace for? Never mind. Where? Where is this? 5. Line number 5. Oh. No. On all the arrays. Pretty weird. So let's print the array anyway. It's no obvious. So it's a no here, which is correct. Now 1849 is a no by our checker, but I think it's looking pretty good. In fact, that is the correct. That is the answer they told us. And this one is pretty wrong. So the sorting is not working maybe. So sorting is fucked up. What can we do? If we try So what can we do? Plus, why is this showing a no when this is basically satisfying every criteria ever? So our checker function is wrong and our solution is also wrong. Let's see why our checker is wrong. So instead of doing all of this shit, what we could have done was, if b of I is, so b of I minus 1 is less than b of I, and b of I is greater than b of I minus 1, right? I plus 1. Right. Then we could have said do nothing, and we could have just not this, and then we could have said flag equals false break. Right? We could have done that, but we didn't. And that's the show. Why are we having a int here? Are we no? Are we no? Let's refactor this, but why would this make a difference? Because we're literally doing the opposite of that. So let's see what condition might have been filled here. So we are at 0th location. We saw that this is greater and n minus 1 is greater than b of a. So this should not be false. So this should be, so b of I plus 1, b of I plus 1 is smaller, which is not the case. So b of I plus 1 is greater, and the last element is smaller. So this is some one case where this should not return true, which is correct, right? So let's go for the next thing. So the next thing is basically 8, and 8 is surrounded by two smaller letters. So basically we'll go in the condition where this is lesser than this, and but this is greater than I minus 1. So in that condition also, that condition we would print false, but here that is not the case. It is lesser than the first one but greater than the other one. Oh sorry, greater than both of them. So I could actually just refactor it like this. and I could actually store this b of I plus 1 inside like comparator end value, right, e. So we can also say end start is equals to b of I plus 1 or previous or next, what we do. So right, so we don't need all of this shit. We can close this shit and copy this. So for the last one, only the index will change. Last index, that will be of 0. And this one, only the starting will be changed to n minus 1. And we'll also have to change. So I forgot one more thing here. So if it's greater than both of the adjacent elements, or it is lesser than both of the adjacent elements. Right. So this, and then the note of all of this. Right. We could just check it outside, right? Since we are taking this. Oh, but we are declaring this inside. Fuck. Let's just do it here. Could have refactored a lot of more code. Okay. This is not about writing clean code right now, please. Function definition is not allowed here before the what? What did I do now? At the end of input. I don't get it. I did not change any fucking thing. Okay. These parentheses are balanced, these are balanced. These are not balanced, I guess. So let's balance them. Else is balanced. So we just need another, I guess. If, else if, whatever that is. How do I keep saving the code? At least that one is working. So the checker is working fine. And now we need to fix our method. So we were doing a wrong method till now. Because shifting the adjacent elements won't work. Shifting the adjacent element doesn't work because there can be three same elements. And in that case, what ideally we want is pick like a small number, start from either a small number or a large number, and keep on adding to it, right? So we can either add from the, so we pick a small number and you go large, small, right? We can also, okay. Now the question is that if we pick, we can start either from small or we can either start from the largest number, right? And also the dilemma, like if I start like if I start from the largest number, now the smaller number from that, should I place it here and or here? And let's say if I place the smaller number here, then now I have another number. If it is greater, like greater than this, then I have two positions, this and this, and can place this k at both the positions. Now where should I put? And so this means this is not a greedy problem or something like that. This is a DP problem. Is it? Because we have two choices. We can either place this here or here. And none of them actually states that. Like we cannot ensure that this will be the optimal position such that if there were to be a wave, then this would be placed here. So we need to try all possible combinations, and whenever we have to try all combinations, we have optimal substructure. Do we have overlapping sub problems here? Do we know? Because maybe we have. I have no idea how I'm gonna do this. I have written the check function though. Okay, let's try this. I sort the array, then I go to the mid, and if it's like even, when I go to the mid, I take one from the first, like the starting index, and then I take the second from the mid index, and third from the starting index, fourth from the last, and so on. But I'll still, how will I assure that? Yeah, by the same thing. So I'll show that. But why to do that? So should we try this or not? And what if we have an odd number of elements? So if we have odd, we can start from, so for even what I said was, take the smallest 3, let's say the elements are 3, 4, 5, 6, 7, 8, or let's say 2. The elements are these. Then I separate them into 2 groups, and first I place this, and then I place this, this, and then this, and this, and this, and this. Right. And if the elements are odd, then I need to start with the elements that have like more number of numbers, and then go on. Yes, so by doing this, I'm gonna be ensuring one thing. Yeah, let's do it. So I can create an array then. It's a C of n. Right. I can take an index idx is equals to 0, and I can traverse this array by doing a for loop, and by 2. And instead of a swap, I just add it to a C of index. A of I. plus plus, and basically this will add a 2. So if the number is odd, 5 by 2 would be actually 2. So, but we want to start with 3. No. So we can do this in the second part, and the first part we can start from n by 2 plus 1. So if it is 5, then this would be 2 plus 1, that is 3. Or we can go here to minus 1, because this would be 0 and 1. This would be starting from 3 or 2, sorry, going up till n. So this loop is going from 2, 3, 4. So 3 elements, and that will be 2 elements. Yeah, so oh shit, I should have done it in one loop. Let's take another variable j, and let's just say that, okay, do we have to do it in 2 loops? I guess. Can we do it? No. So if I want to write one loop, if I is less than n by 2 minus 1, then I'll add it to what? What am I even doing? This is like the length I want, right? So this is the length I want, and not the guy I want. So if I mod 2 is equals 0, so since it is even, then that means if I start with 0, then I'll end with an odd number, so it doesn't matter. So this. I don't even know what I'm writing, but it feels good. J go from n by 2 to n, idx, and I go from 0 to n by 2 minus 1, and that will be taken care of by what? अगर आई इन्वर्ट से कम होगा और जे भी अगर एन से कम है तो यही करेंगे। और अगर जे या आई में से कोई एक ख़त्म हो जाता है जो कि आई पहले होगा तो जे में अभी भी बचा होगा तो हम लगा देंगे। सो ये हमने एक लिख दिया है। बेसिक कोड जो कि एक सी में डाल देगा alternating values and we can pass this to the check function and we can basically check from that. The only problem that is left is let's see if this comes out to be like this 111 time limit yes, oh, okay. Come on, this should work. What? This should come first or what is going on? Since index plus plus is always going on, can leave this out. What if none of these is happening? Oh shit, that is correct. Everything is good. Just to explain my approach, what I'm trying to do is, let's say 2, 3, 5, and let's say 6. Right, this was the array, so this was an even array. So I'm splitting it into two halves. 2, 3, 5, 6, sorted. This is sorted. So now I have two arrays, 2, 3 and 5, 6. First I'm writing 2. Sorry. Okay, yeah. So they have equal length, so I can write any one. So then I'm writing 5, then I'm writing 3, and then I'm writing 6. Right? If this were to be an odd number array, then what typically we would do was take this thing, go to 5, then 6, then 7, and then we go to 3. So now we have C of I like this, right? But somehow that C of I is not coming as expected. Oh, I'm actually not swapping it. No, I am swapping it. I'm not printing it. यही तो अंदाज़ है। I get it. मन नहीं कर रहा यार गिव अप करने का। Okay, this is not displaying C of I, but we want C of I. Oh no, this is getting fucked. Even this is wrong. इससे क्यों हो रहा है? ठीक ठीक